There's homework due tonight. It's the last homework assignment. Homework number 12. Okay, we're going to finish the notes for homework 12 so that you can understand how to do the last part of the assignment. And there were 4 quizzes, only 4, 12 homeworks. The final exam will be available this Friday and due next week on Friday. So from the 10th to the 17th, it's going to be posted to Canvas. It has 10 questions. I mean, and it's set up like the past exams, but we'll talk about like the exam when we get to the review. Okay, the 17th. Oh. The 17th is the last day of the semester. After this, I'm going to work on your final grade and post that to the official grade book. So after the 17th, you can't turn any assignments in or work on any quizzes or exams. But if you want to make up assignments between now and then, this week and next week, just send an email. Try to improve your grade before the 17th. Okay, and next week, you're working on finals and we have no Zoom meetings. I'm available, but I don't plan to log into the office hour unless someone makes an appointment. So no Zoom meetings next week unless you want to write to me and we can set up a time to meet. We can meet during our class time or during my office hour time. I'm pretty available next week, but not all. Okay. And now we do notes for homework 12. Is an assignment about logarithms, or they're called logs. So there's a few things to watch for. The base of a log is a positive number. We're going to call the base B. Some real number that's greater than 0. Base is also not equal to 1. The last part is that the input of the log function, which we call the argument, is a positive number. So all your inputs x and they are greater than 0. Log base b. So the function's name is log, and then the base is like a subscript. This is the input, or it's also called the argument of the log, and you input your x value. And the output, whatever number this is y. And this is equivalent to, which we use a double-sided arrow. That one is equal to the other. One implies the other and the other way around. Take that base b, raise it to a power y, set it equal to x. This is called log form, and then this version is called exponential form. I'm going to work on writing problems from exponential form to log form, which we started to do last time, but we can, of course, use more practice. I did 2 of these for part A. 5 cubed equal to 125. This is equivalent to what I look for is a base with exponent. This side has the base 5 and an exponent 3. So use 5 as your log base. And then that exponent is what the log is equal to. 3 on this side. We've got the log base 5 of 125. So yeah, this base, the power equals some number. That other side is your argument, this part here. Or sometimes once I've written this down, just work from here and double check that they do match. You take the base 5, raise it to power 3, so it equals to 1. Okay, let's try another. When you have 0.01 equal to 10 with the power of -2. This is equivalent to see, this side has a base 10 with the power -2. So use this as the base of the log. So I like to work from here over this way. I would want to take that 10, raise it to the power, which power is -2, and put it equal to the argument, which is that side, 0.01. Okay. Let's practice going the other way. Go from exponential form, or from log form to exponential form. We have log base 2 of 8 equal to 3. And this is equivalent to 2 raised to the power 3 equal to 8. I know there's a lot of arrows already, but it might help to draw. You take this, bring it to this power, set that number equal to okay. We write log base 7 of 49 equal to 2. Okay, from here to here, it's equivalent to 7 raised to power 2 equal to 49. Next one, part C, we'll look at log base 10 of 0.001 is equal to -3. Which is equivalent to, or sometimes you could say, some people might say like if and only if. You take 10, raise it to the power of -3, and that's equal to 0.001. Last one for this type of example. D. Log base 3. of 1 over 81 is equal to -4. If and only if 3 with a power -4 is equal to 1 over 81. Take the base, raise it to this exponent, set all of it equal to the argument. Okay. Then we're going to solve a couple problems by switching from log form to exponential form. Okay, so log base 5 of x equal to 2. So we're going to do scratch work, just copy down the problem. So you can use a double-sided arrow, or you can just use one arrow to say like this would imply the next thing. I'm going to stick with the double-sided arrow. Take 5, raise it to a power 2, set it equal to x. Okay. And then 5 squared is 25, so x is equal to 2. Another one where you solve. This time, take log, it has base 2, -16 inside, and this is equal to, you know what, we're going to call this W. So there's two things, or two ways I would like to explain why there is no value that we can find for W. Okay. First thing, because I've kind of looked at this problem a few times, that number inside of the parentheses, which we call the argument, needs to be positive. So since this is a negative number, there is no solution, there is no value for W that makes this possible. Okay, -16 is less than 0, and we need the argument of the log, which is whatever number is in the parentheses, which is your input for this function. Or another way you could look at this is you kind of forget that this number needs to be positive and go ahead and switch to exponential form. Take 2, put it to a power of w. That would be equal to a negative 16. Okay. Even though I could factor 16 and get some base 2, there's no value that I can bring positive 2, multiply it with itself some number of times, and somehow get a negative 16. So, no solution. There's no w that's possible for this. Okay, next part, we're going to solve for x. Log base 8 of 4 equal to x. Okay, let's just copy down. Take that base of 8, bring it to the power x. So that equal to 4. Okay, let's start with factoring 8 as 2 cubed. Okay. And then on this side, that power to that power will be multiplied together, and it'll be 2 power of 3x equal to 4. Okay, there's a result for having the same base. The exponents would be equal to each other if we had a base of 2. So let's rewrite 4 as 2 squared. Okay, so the bases match, but we have a matching base of 2. It means that 3x has to be equal to that 2. Size by 3, and you'll have x. X is equal to 2/3. This is the last example for the homework number 12. Solve this. Log base 9. Of 1/3 is equal to x. It's going to rewrite the. Okay, and then we'll switch to the exponential form. Take 9, put it to a power of x, and then set it equal to 1/3. And I'm going to use the same idea of getting a base that matches. I'm going to try base 3. And then if I can't have both sides with a base of 3, we'll put the exponents equal to each other. So factor 9 is 3 squared. So on the sides, 3 with the power of 2x. Put this 3 up into the numerator, its power will become negative, but it has a power of 1. So we'll rewrite it as 3 with a power of -1. Okay. Now that I've got that base 3, the exponents have to be equal to each other. We need 2x to equal -1. Then divide both sides by 2 to get -1/2 equal to x. So this should be enough to help with your homework. If you need more time on the homework or have questions, you can write a message through XYZ or just to my email. Okay, wait. Let me see. 3, 2, 2x. Another question. I'm going to probably just go through the problem again, but just how I got this all set up. So just walking through this, plus it's good to check that I did it correctly. You take log base 9. Argument is 1/3. It was equal to x. And then I put 9 to the x equal to 1/3. And then I took this 9 and factored it as 3 squared. So let's replace that with 3 squared. And then 9 still has the power x. And then this is where, like, from this step to the next, when you have a power raised to another power, you multiply those numbers together. So keep the base 3 and the power is 2 times x. Then we're here again. 3 is the base, 2x is your power. And we started working on rewriting this side. Into the numerator, change the sign to negative. And then exponents are unique. So if you have a base 3, those exponents equal each other. We could do another example too, if that may help. Let's see. Let me try one more example. Okay. So if log base 8 equal to x. I'm just going to copy down the problem and then change to exponential part. So we'll take 8, put it to the power x. And then it's equal to 1/2. Okay, and then this time we're going to replace 8 with 2 cubed. Well, you could do a factor tree first. So just on 8, it's 2 times 4. 4 is 2 times 2. So 2 cubed would be 8, and then it has a power of x. And this would be 2 with the power of 3x equal to 1/2, or 1/2 to the first. And then we'll bring this 2 to the first up into the numerator. It's 2 to the negative 1 power. This time we have a base that matches, and the base is 2. And that means 3x is equal to negative. So x would be negative 1/3. Now we're going to switch to getting ready for the final exam. So I picked a question from pretty much every homework assignment and just changed it a little bit. And then I made the review just examples similar to those kinds of questions. Mentioned earlier, there's going to be 10 questions on that test. And you have about a week to work on it. It will be posted to it is posted to Canvas. It's just not available till Friday. When you start to work on the test, there's no time limit. There's unlimited attempts, and I'll give you the highest score. And you don't have to show your work, but it helps if you make a mistake and they see where the mistake happened. I can grade it a bit better. Okay, so the first kind of question is about intercepts, getting x-intercepts and y-intercepts. And then the equation is 10x plus 5y equal to 20. So you're getting 2 points, a point where you find some x value and the y value is 0. And here, this point has an x value of 0, and then you get the y. Let's start with your x-intercept. Here's when y is equal to 0. 0 into that part of the equation. Solve for x. Okay, then 5 times 0 is 0, so what's left is 10x equal to 20 divided each side by 10, and x is equal to 2. Okay, so you could either put x equals 2, or you can write a point 2, 0. And then you find the y-intercept. The y-intercept is going to be the point where x equals 0, and you find out what y value is. So 10 times 0 plus 5y equals to 20. So this is a 0, y, and it's equal to, oh, so there's a question about y0. I'm going to finish the call, then I'll explain why you pick 0 for intercepts. Equals 20. Y would equal 4. You could put 4, put 0, 4. X is equal to 0. So first I'm going to note, it's not always the case that look at some point on the line, like you don't want to put 2 with 4. You have the point 2, 0 and the point 0, 4. Those intercepts could help me draw the graph, and I think a picture of the graph will help explain why you pick 0 for different parts of the intercepts. So let's say, sketch this line. X's and Y's and some units. So I am confident that we found the right intercepts, and I'm going to use those 2 points to draw the line. I kind of want to do an extra example where we draw a line and then find out the intercepts maybe. Okay. Plot 2, 0. And 0 for x, 4 for y. Those are 2 points on the line, so just connect them. Label this point. So let's see, the x-intercept occurs when the line or when the graph intersects the x-axis. And when you intersect the x-axis, the y value right there is always going to be like not moving up or down, it's right at 0. So you need that y value to equal 0. X-intercept. Okay, the y-intercept happens when your graph touches or intersects with the y-axis. Right. And when that happens, we've gone up some value for y, and then x, like when you hit this axis, x can't be moving left or right, it has to be at 0. So it kind of is a part of the name. The y-intercept occurs when x equals 0. The x-intercept will always occur when the y value equals 0. Okay, let's do another example of a line. Let's go with y equals negative 2x plus 1. X values, y values. So to graph this, we could go to 0, negative 1, or positive 1 on the y-axis. It would be down 2 and to the right 1. Let's just use those 2 points to draw. Right here, you've crossed the y-axis. That's your y-intercept. Right there, which we're going to have, I think we'll go ahead and do the math to figure out what number that is. Right there, the line touches the x-axis, and that is your x-intercept. So for the y-intercept, you go up some number y, but x is 0, is right there on the axis. And then for the other point, you go over some number x, but the y value is 0. It doesn't go up or down. It's like right where it touches the x-axis. Okay, we're going to get those points. One of them's kind of easy, that one. And this point over here was just helping you draw the line. You don't really need it when we're talking about intercepts. So let's get the x-intercept first. So to know what that point is, you have to put y equal to 0 and then get whatever, that point over there. Y is 0 and get whatever x value it is, which is some positive number. Looks like it's probably less than 1. We'll find out. 0 on this side. Negative 2. Plus 1. So I could add 2x to both sides. And divide both sides by 2. Okay, so that point is over 1/2 for x, 0 for y. Okay, and this is the y-intercept, where y is some positive number. We'll find out what number it is. And x is equal to 0. So it's a 0 right here. Y is equal to -2 times 0 plus 1. So y is equal to 1. This is just going to be 0. Okay, so the point is x, y, where x is 0 and y is 1. It's that point right there. Okay, next is to find the equation of a line that goes through 2 points. Thank you for asking that question, by the way, and feel free to ask questions during the review. I've got the chat on this side. Okay, the first point is 2, 3. The other point is 0, -5. Okay, so there's a couple different ways to find that line. I like to use the y equals mx plus b, which I think is called point, or no, it's called slope intercept form. That's just my suggestion. Okay, you have to find m and find b, and then write out the equation, like once you know those numbers. M is the slope. It's the difference in y values divided by difference in x values. So let's call this point the first point, and this will be x1 and y1. And then x2, y2. Plug in y1, which is 3, and then we're going to subtract -5. 5 by 2 minus 0. So in the numerator, there's 8, and then we're dividing by 2. 8 over 2 is going to be 4. So okay, so got part of the equation, y equals 4x plus b. Okay, now either point would work to get that number b. I kind of like the point that has 0, but again, you could pick this point if you want to. Let's try -5 for y, 0 for x, and then solve for b. Cool. Right. Like 0 because this number is 0. B is -5. So y is equal to 4x plus -5, or y equals 4x minus 5. That's the equation of the line that passes through those 2 points. One more problem like this. We're going to get the equation of a line that goes through 2 points. First point is -2, 2. The point is 4, 5. Alrighty. So, like most of our problems, there's different ways to reach the same answer. But I like to do these with the y equals mx plus b form. And then you start by finding m. Once you get m, pick one of your points to figure out b. And then put everything back together in y equals mx plus b. Is the difference in y values divided by difference in x values. doesn't matter how you like pick points, and this could be x1, y1, or x2, y2, or the other way around. X value followed by the y value. So x2. Okay, in the numerator, take 2 and subtract 5. And we're dividing by -2 minus 4. Okay, so this would be -3 over -6. Which would be positive 1/2. So we've got the slope, and we're piecing our equation together. Y equals 1/2 x plus b. We need to know b. Either of the points would work. Kind of like this point better for some reason. So we'll pick x equal to so I need 5 on this side. So it equal to 1/2 times 4. Then add b. Okay, 1/2 times 4, or 4 divided by 2 is 2. Then subtract 2 from each side, and I get b equal to 3. So then after I put this into the equation, we're done. Y equals 1/2 x plus 3. Next is to practice some exponent rules. So I've got 2 examples. The first one, we want to simplify and then write the answer with positive exponents. Okay, let's see. 4 multiplied with x to a power -2. And the x value is then raised to a power of 3, and then divide everything by x with power -3. Okay, let's just copy this down. So this 4 is just multiplied outside of the parentheses, so we copy it down. It's that x value that has a power to a power. We'll multiply those powers together and get x to a -6. It's over the x to the -3rd. So there's different steps we could take. I think I would like to bring this x to the -6 down to the denominator, so it's x to the power of +6. But that +4 would stay in the numerator. Or over x to a power of -3 plus 6. So 4 over x cubed. Okay, and another where we want to use exponent rules to simplify and write with positive exponents. Okay, we're taking a to the -4th, b to the 5th. A to the -4th times b to the 5th, and then times a to the 3rd, b. A to the 3rd times b, and that has a power of -2. Okay, I'm just gonna copy it. I think the first thing I thought to do was take care of this power -2. One way to do this is I could bring everything in the parentheses down into the denominator and it would have a power +2. Or I could just raise a cubed to -2, put b to -2. Either way works. It's going to bring this whole piece into the denominator. try a to the negative 4, b to the 5th. That by all of this down below, so a cubed b power positive 2. Well, it seems like I still need to apply that power to both variables, a cubed squared and then b squared. Let's copy down the numerator. A cubed squared will be a to the 6th. We'll multiply those powers together. And then b to the power of 1 times 2, which is 2. Let's take care of the variable b. B has a power of 5 minus 2. Will be in the numerator. All right, so if I've got a with the power -4 times b with the power 3 divided by a to the 6th. Now we need to take care of the variable a. We just want 1 base a. That variable just show up 1 time. Let's bring this a to the -4th down to the denominator. Give it a power of +4. Multiplied with that a to the 6th that's already down there, and then the b cubed needs to stay. Okay, almost done. That base a has a power of 4 plus 6. B cubed divided by a to the 10th. We're going to do one more problem and then we'll come back next time to keep on practicing for the final. This time we're just going to multiply, and the goal is just to practice using the distributive property. Okay. 1/5 multiplies with 25x. Subtract 5y. And add. So we'll take this fraction, 1/5, and multiply it with all 3 terms, which means we're going to distribute it 1/5 times 25x. Subtract 1/5 times 5y. Add 10 times 1/5, which I'm going to put just the 10 over 5. So this would be 5x. Subtract y. Add 2. If you had any like terms, you'd want to combine them, but this is a x value, a y value, and some number, so we can't combine like terms. Just leave it like that. Okay, I think we're gonna end there. We can always come back next time to practice the distributive property. So again, Thursday, we do meet. We finish the review for the final exam. I don't have an office hour tomorrow, but I am available Friday. So let me know if you need help. Okay, thank you for coming to class. Have a good day. Thank you.
Have a nice day, Professor.
We're all good to go.